Scientists may finally know what's at the edge of the universe. The universe is vast, incomprehensible, and seemingly infinite. Over the centuries, humankind has made strides in understanding its structure, origins, and the forces that govern it. One of the most intriguing questions has always been, what lies at the edge of the universe? For many years, the concept of the edge of the universe seemed almost nonsensical due to the theory of cosmic inflation and the nature of space-time itself. However, recent breakthroughs in astronomy and physics are shedding light on this elusive question, bringing us closer to understanding the farthest reaches of the cosmos. #, the expanding universe. To understand the concept of an edge, it's important to first grasp the nature of the universe itself. The universe is expanding. This discovery was first made by Edwin Hubble in the 1920s, when he observed that galaxies were moving away from us in all directions. This is now known as Hubble's law, which states that the farther a galaxy is from Earth, the faster it is receding from us. This observation led to the conclusion that the universe had a beginning, a moment in time when it was compressed into an incredibly dense and hot singularity, what we now refer to as the Big Bang. Since then, astronomers have realized that this expansion is not just a movement of galaxies through space, but rather an expansion of space itself. As space stretches, so do the distances between galaxies, and this is a key concept in understanding the edge of the universe. #, the observable universe. When scientists talk about the edge of the universe, they are often referring to the observable universe. This is the region of space from which light or other signals has had time to reach Earth since the beginning of the universe. Given that the universe is approximately 13.8 billion years old, the observable universe extends about 46 billion light-years in every direction. However, this does not mean that the universe ends at this distance. The observable universe is simply the part of the universe that we can observe with our current technology, limited by the speed of light. Beyond this distance, there are regions that are beyond our observational reach, simply because the light from those regions hasn't had enough time to travel to us. #, the edge of the universe. Theoretical perspectives. For much of modern science, the edge of the universe has been more of a theoretical concept than a physical location. According to the most widely accepted model of cosmology, the universe has no traditional edge. Instead, it is infinite in all directions, stretching beyond the observable universe into regions we cannot see or even imagine. This idea stems from the fact that space itself is expanding and that the universe may have no boundaries. It is simply infinite in nature. One of the most significant advancements in this area is the study of cosmic inflation. This theory proposes that the universe underwent a rapid expansion in the moments just after the Big Bang. During inflation, the universe expanded exponentially, far faster than the speed of light. This would explain why the universe appears homogeneous, the same in all directions, and isotropic, looking the same from any location. If inflation is true, then the universe extends far beyond the regions we can currently observe, potentially even into realms that are fundamentally unobservable. #, dark energy and the accelerating universe. In the late 1990s, astronomers discovered that the expansion of the universe is accelerating, not slowing down as they had previously thought. This surprising revelation was made through observations of distant supernovae and has since led to the hypothesis of dark energy, a mysterious force that seems to counteract gravity and cause the universe's accelerated expansion. Dark energy's role in the universe's expansion adds a layer of complexity to the idea of the edge. If the acceleration continues, distant galaxies will eventually move beyond the observable horizon, unreachable by any future observations or communication. The concept of an edge in this context becomes a moving boundary, one that shifts farther away as the expansion continues. This dynamic edge is not a physical structure, but a limit of what we can observe. #, multiverse theory and parallel universes. Some physicists, taking inspiration from quantum mechanics and string theory, have proposed the idea that our universe is just one of many in a multiverse. According to this theory, there could be an infinite number of universes, each with its own set of physical laws and constants. In this multiverse model, the edge of our universe is just a local feature, with no connection to any boundary beyond our observable space. The idea of a multiverse would mean that the true edge of existence lies far beyond our universe, in a realm that is entirely separate. While the multiverse theory remains speculative, it opens up intriguing possibilities. If there are multiple universes, there could be entire realms with different dimensions, time flows, and even laws of physics. The edge of our universe, in such a scenario, could simply be one universe in a much larger and more complex structure, where boundaries are undefined. #, new discoveries and observational frontiers. Recent advances in telescope technology, such as the James Webb Space Telescope, JWST, are providing unprecedented insights into the distant past of the universe. By observing light from galaxies that formed just a few 100 million years after the Big Bang, astronomers are able to peer deeper into the universe's early history than ever before. These discoveries are pushing the boundaries of our understanding, revealing new details about the structure of the universe, its expansion, and the nature of its edge. Additionally, the study of cosmic microwave background radiation, CMB, has allowed scientists to map the earliest stages of the universe. The CMB is a faint glow of radiation left over from the Big Bang, and it provides a snapshot of the universe when it was just 380,000 years old. Analyzing the patterns in the CMB allows cosmologists to make predictions about the structure and fate of the universe, including its possible edge. #, the future of cosmology. As technology improves and our understanding of physics deepens, we may one day have more definitive answers about the edge of the universe. However, the true nature of this edge may remain elusive. Whether the universe is infinite or finite, expanding ever outward or destined for a big crunch, our concept of the universe's edge will continue to evolve. In conclusion, scientists are indeed making strides in understanding the universe's edge, but it is clear that the answer is not straightforward. Whether we are talking about the observable universe, the limits of cosmic expansion, or the speculative notion of a multiverse, the edge of the universe is as much a question of the limits of our understanding as it is a physical boundary. Each discovery pushes the boundaries of what we know, bringing us closer to unraveling the mysteries of the cosmos, but the full extent of the universe and its edge may remain a mystery for some time to come.